As we know well, if y is equal to sin x, then dy upon dx is equal to cos x, or we may say that the differential coefficient of sin x is cos x. And here we are going to prove it with the help of first principle. So let y is equal to sin x. Let it be equation number 1. Now let delta x be the increment given to x and delta y be the corresponding increment, increment in y. So the equation number 1 becomes y plus delta y is equal to sin x plus delta x. Transposing y to right hand side, we have delta y is equal to sin x plus delta x minus y. Now substituting y is equal to sin x, here in this equation we have delta y is equal to sin x plus delta x minus sin x. Now applying the formula sin c minus sin d, we have 2 cos x plus delta x plus x upon 2 into sin x plus delta x minus x upon 2. Here in this bracket, positive x will cancel negative x, and we have simply 2 cos x plus x 2x plus delta x upon 2 into sin delta x upon 2. Now dividing both sides by delta x, we get delta y over delta x is equal to 2 cos, here if we split these two terms, we have x plus delta x upon 2, and here sin delta x upon 2 upon delta x, because we have divided both sides by delta x. So we have delta y upon delta x, and here on the right hand side we have written delta x in division of sin delta x upon 2. Now taking limit delta x tends to 0 on both sides, limit delta x tends to 0, delta y over delta x is equal to limit delta x tends to 0 to cos x plus delta x upon 2 into sin delta x upon 2 upon delta x. Now you can see this 2 can be written in the denominator of delta x, because any number or expression can be shifted from the numerator to the denominator of denominator. So we have limit delta x tends to 0 cos x plus delta x upon 2 into sin delta x upon 2 divided by delta x upon 2. And as we know, the standard limit x tends to 0 Sine x upon x is equal to 1. So on the left hand side, by the definition of derivative, limit delta x tends to 0, delta y upon delta x is denoted by dy upon dx. So we write dy upon dx on the left hand side, and on the right hand side, applying this particular limit when x tends to 0, delta x upon x is equal to 1. Same structure we have here, sine delta x upon 2 upon delta x upon 2, where delta x tends to 0. Because if delta x tends to 0, then delta x upon 2 must also tends to 0. So applying the limit, we have here cos x plus 0, because if we substitute delta x is equal to 0 in this bracket, we have x plus 0, and applying the standard limit on this expression, we have 1. So ultimately we have dy upon dx is equal to cos x. So we have proved if y is equal to sin x, then its differential coefficient, that is dy upon dx, is equal to cos x. If y is equal to sin x, its derivative is cos x. In the same way, we may prove the derivative of cos x is minus sin x. So you better try yourself with the same algorithm.